Good morning, everyone. Again, myself, Pathak Sumer, working as an assistant professor in Sinhagad Institutes. Now, when we are going to look towards first slide, there is a one animation where hot water from underground is entered through a well in a chamber. This hot water gets converted into steam and which will helpful to rotate the turbine. As the turbine rotates, generator is connected to it and because of which electricity is generated. This electricity is passed to our household or industries. The water left out from turbine is entered in the cooling tower and it will again pass through another well and into the ground. As I told you, my introduction topic which we are going to learn from this video is different types of non-conventional energy sources. Just like geothermal energy, tidal energy, ocean thermal energy and wave energy. So first we are going to learn geothermal energy. As I told you, there is a hot water which is always present below the rocks which is entered through one well and gets converted into steam. It passed through the turbine, electricity is generated and cooled water is passed through another well into the ground. This is called geothermal energy. Now geothermal, it is the word made by Greek word geo means earth and thermal means heat. When we combine both the words, we will get a definition for it, that is the heat energy used from earth and it is useful for human comfort, that just like as to produce electricity. When we look towards this animation, we know that earth, inside the earth there is a high temperature, that is near about 500 degrees centigrade temperature is present at the center of earth, but we doesn't feel it because of various layers of rocks are over it and because of which we don't feel that much of high temperature. But when there is a volcano eruption, that is magma is interrupted, then we will feel much more temperature. When we see through this graph that per kilometer near about 30 degree Kelvin temperature variation is there, which is shown in this graph. So when we see our earth, then it is the earth crust. Below this earth crust there is a mantle, outer core, inner core and so on. If we see rainfall, rain is going to fall on the earth crust and till geothermal reservoir. Then this water again gets converted into hot water spring because of this heat or the magma which is heated. This magma will heat the water and water vapors comes outside. This energy is used for generation of electricity is called geothermal energy. Now how geothermal energy works? As I told you, this number one is nothing but our magma, water well or water reservoir located at number position 2. This hot water is entered through the turbine which is given as number 3. You can see here also, and turbine is coupled with generator or both are attached one. Now as the turbine rotates, generator also starts to rotate and because of it electricity is generated and through transformer it is passed to our household or for requirement just like in industry. The remaining water from this turbine is again passed to cooling tower which is at 8 number through condenser. Now this water is again passed through another pipes. Now there are two different types of steam power plants. First is a dry steam power plant. Just see here through the steam turbines, turbine gets rotated and electricity is generated. But here when we see the dry steam, then magma is going to heat the water's reservoir or water and this water gets converted into steam which we are going to use to rotate the turbine. So it is called a dry steam power plant. Now, second one is flash steam power plant. Means along with water, there is also some impurities present in it which are going to be cleared, and then these water vapors are passed into the turbine, then again generator generates electricity, and then we will get it. Remaining wastewater is passed through another pipes into the well, another well. Water vapors or hot water comes through one well, and remaining or wastewater, we can say it as a waste brine, is passed through another well again in the ground. Cooling modes. We will see this is the first purpose of geothermal energy, that is to produce electricity. But apart from this, there are another purposes, that is to heat the room. We are going to use geothermal energy. Now, there are two different modes. Cooling mode is there and heating mode is there. When during cooling mode, hot air is required inside the room, therefore hot air is passed. During heating mode, cool air is required, so cool air is passed. Such types of mechanisms are used with the help of geothermal energy, that is room heating applications. According to Geological Survey of India, India have near about 340 geothermal hot springs present in the countries. You can see here the animations from USA, how the hot springs are there. Most of the hot springs having temperature 37 to 90 degrees centigrade. For example, Puga at a distance of 180 km from Leh Ladakh in Jammu and Kashmir, where the hot spring temperature varies from 30 degree to 84 degree centigrade, and it will discharge just 300 liters water per minute. Now here this energy we are going to use to generate first of all electricity, and during cold season we are going to use this energy to heat the room, so that we can use this type of geothermal energy for our purpose. Now, classification of geothermal resources. These geothermal resources are classified as hydrothermal, geopressure, and hot dry rock. First, hydrothermal. When we see the animations, we will get some idea that when we are going to observe such types of videos on Discovery underneath or at the bottom of sea. See, in such areas, hydrothermal energy is present. What happens exactly there? The thermal reservoir consists of porous or fractured rocks containing hot water or steam which is in natural state, and it will be transported towards the surface by density driven mechanism. It is also called natural convection of, that's just like as in heat transfer, convection, conduction and radiation. Second source, geopressure. Geopressure, conduction is dominated. As I told you, in heat transfer we learn conduction, convection, radiations. So geopressure is conduction type of heat flow system. The main characteristics is that the pore pressures is considerably greater than hydrostatic. Such reservoirs are exist at a depth greater than 4 km. Remember this point. The territory basins along with Gulf Coast of Louisiana in USA are the examples of geopressure resources. Now the last is hot dry rocks. They occurs in the area of high heat flow but low permeability, and heat is transferred by conduction process. In these areas, temperature exceeds 300 degrees centigrade from 2 to 3 km depth. Dry steam power plant, if we see here the hot dry rock, in this system the heat is extracted by circulating treated water from the surface through well and hot fractured network. Again, the purpose is to generate electricity. Now, advantages. Geothermal energy is a renewable type of energy or renewable source of energy. As we know, renewable energy sources means these are eco-friendly and non-polluting type. There is no wastage or generation because it is naturally we will get this type of energy. Geothermal energy can be used directly. In ancient times, people use this source of energy for heating the homes and cooking. Disadvantages. sources. Only few sites have the potential of geothermal energy. Most of the sites where geothermal energy produced are far from markets or cities. Total generation potential of this source of energy is very small. There is always a danger for eruption of volcano. As we saw here, these are the energy sources which are obtained 2 to 4 kilometers below the application. This energy is used for electricity generation in the countries just like Iceland, Salvador, New Zealand, Kenya and Philippines. More than 90% of heating is demand in Iceland. It is not depending on the weather conditions. Geothermal power plants are capable of supplying base load electricity. Thank you.